All right, so the next thing we want to talk about is something called the discriminant. And the discriminant is the part of the quadratic formula under the radical, right? Because if the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a, notice b squared minus 4ac is the part under that radical. It's a nice thing because it does tell us something about the actual equation that we're looking at without having to solve it all. So I'll say the discriminant b squared minus 4ac is equal to 0. Then I really have negative b plus or minus 0. I would really just have negative b over 2a. So I would have only one real solution. Now, if the discriminant is greater than 0, so now what's underneath that is greater than 0, right? So I can take the square root of that because it will be a real number as long as it's greater than 0. Can you see that I'll have two real solutions because I'll have the negative b plus the whatever that is, and I'll have the negative b minus whatever that part is. So if I know if b squared minus 4ac is positive, then I know I have two real solutions. And if the discriminant is less than 0, so now I have the square root of a negative number. So what I have is 0 real solutions, or I can say I have two complex solutions. Literally just from the discriminant, I can tell a lot about it. If the discriminant is equal to 0 and I have one real solution, what that means is if I graph it, I'm going to hit that x-axis in only one place, right? Because if I have only one real solution, that means that I have one x value. I don't have two x-intercepts. I have one x-intercept. So it could look something like this, or it could look something like this. But basically, it's hitting the x-axis in exactly one place because it's only got one solution. If my discriminant is greater than 0 and I have two real solutions, that means I know what the graph approximate looks like. I know it's got to hit this x-axis in more than one place. It can go like that, it can go like this, but it has to hit the x-axis in two places somehow because I have two solutions and my solutions are really where the x-axis is, okay? And if my discriminant is less than 0 and I have 0 real solutions, let me just get a different color so it doesn't slide. So what that would mean is I would never hit the x-axis because I have no solutions. So I can go above it or I can go below it, but I can't touch it because if I touched it, that would be a solution for the quadratic equation.
But it can touch the y-axis though, right?
Absolutely. Absolutely. They all will pretty much touch the y-axis at some point because they go on infinitely in both directions. The solutions have to do with whether or not it touches the x-axis.
Okay.
Okay, makes sense? Okay, perfect. It says use the discriminant to determine the number and type of solutions. So here I have this quadratic equation and I want to find my discriminant. And remember, my discriminant is the part that's underneath the radical, which is b squared minus 4ac. So I can just plug them in. So here I'll say a equals, what does a equal?
12.
Good. B?
4, -4.
Good. And C is 5. So b squared is 16 minus 4 times 12 times 5. And I don't even care what the value is, do I? I can tell pretty easily that this is less than 0. Because 4 times 12 times 5 is way bigger than 16. So since we know that the discriminant is less than 0, it's going to be negative, and the square root of a negative number is complex. So what I have is 0 real solutions, or I could say 2 complex. All right, so now we want to talk a little bit about graphing. So whenever we graph a quadratic, it's always going to graph to a parabola, and we've seen what a parabola looks like. And so if I have a parabola, this point right here, or if my parabola is upside down, this point right here, those are called the vertex, and this is the highest or lowest point. Okay. So I can always find, if I can graph something into a parabola and I want to know what the minimum value is, and it opens up, it's going to be this. And if I want to know what the maximum value, it opens down, it's going to be here, right? And the axis of symmetry always runs right through the vertex. Hopefully a lot of these things are things I'm hoping not only you know, Alex, but everybody in the class knows. Hopefully you've seen these before. I'm pretty sure you have. I'm just saying in general. Sometimes I'm going to talk to you specifically, and sometimes I'm going to talk to the whole class. Okay, so don't worry about it. So if the quadratic equation is written in this standard form, and A, so we're really only looking at the leading coefficient, then when A is greater than 0, the parabola opens up. And when A is less than 0, the parabola opens down. And whenever you want to know where the vertex is, if it's written in this form, it's going to be negative b over 2a. And if we go back to the quadratic equation, notice how all this is coming from the quadratic equation.
Mhm.
So our b squared minus 4ac has a purpose. That's our discriminant. And here, notice, here is the x value of the vertex, negative b over 2a. So if you remember the quadratic formula, you can kind of remember all these different pieces, okay? And so once I find what my x value of my vertex is, I can then plug that into my equation and find the y value. So for example, here I have, it says graph, I want to graph this quadratic equation using the vertex formula. So what is my vertex formula? My vertex formula says that my x value of my vertex is going to equal negative b over 2a, which is going to equal negative 8 over 2 times 2, which is equal to negative 2, right?
Mm-hmm.
And then if I want to find my y value, or f of negative 2, which is the same as my y, if I'm going to graph it, I would just say this is 2 times negative 2 squared plus 8 times negative 2 plus 3, which is, so this is for 8 minus 16 plus 3, which is negative 8 plus 3, which is negative 5. So now I found my vertex is negative 2, negative 5, right?
Mm-hmm.
Which is very helpful. So now I can come over here and I can graph it. I have negative 2, negative 5. There's my vertex. Is this graph going to open up or down?
Yeah, normally you look at the A, right?
Exactly. So I
Mhm.
know it opens up. And if I want to be really perfect about it, I can just plug in 0, right? If I plug in 0 here, I get a point, x is 0, y is 3. So I can plot that point right there. And because it's symmetric about the vertex, since I'm going 2 to the right, if I go 2 to the left, it's also going to be positive 3, isn't it? I don't even have to plug in a number.
Yep.
And then I can just put it together. And there I have the graph of this quadratic equation. If I want to graph this quadratic equation, again, I do really the same thing. So I can say, I know that my x value for my vertex is going to be negative b over 2a, and b here is 4, so it's going to be negative 4 over 2 times negative 2, which is negative 4 over negative 4, which is positive 1, right? So I know my x value of my vertex is positive 1. My y value, I plug 1 in, so I get negative 2 times 1 plus 4 times 1 plus 5. So that's 2, that's 7. So now I know my vertex is at 1, 7. And again, 1, 2, 3, 4, 5, 6, 7, 1. So I have a, is this graph going to open up or down?
Down.
It's going to open down because we have this negative 2. So again, I can plug in x equals 0, which gives me a 0.05. 1, 2, 3, 4, 5. So I know it's going to go through this point. And because I've gone 1 to the left, I can also go 1 to the right and plot that other point that's exactly at the same place because it's got to be symmetric, right? And there's my parabola. So the homework for the quadratics looks like this, okay? And it looks kind of scary at the beginning. I don't want anybody to get too concerned about the words in the word problem. I want you to be able to read past it. So I'm going to read it to you the way I want you to read it. So the figure below shows part of a circuit where 3 capacitors are in series and parallel, and also the equation for the total capacitance. Okay, is there anything about that that I need to do my math problem? That just that first sentence?
3 capacitors.
Maybe, but I don't really know what else I need, but maybe, but there's not really much I can do with that. Okay. And then it says the circuit also used direct current instead of alternating current. So all the measurements are real numbers. And I'm given this equation. And it says, suppose a certain circuit has a total capacitance of 15. Those are microfarads. That's like saying inches. Don't get worried any more than you'd be worried if it said inches. And notice it says mu f represents the unit of measure for capacitance called microfarads. This does not to be included in your calculations. So you don't have to worry about that. All you want to do, substitute the values into the equation and get a quadratic equation in C1. Well, the reason we're going to get it in C1 is we're being given t. So I'll just write down, I'll just start it. We have t is 15. C3 is 8. C1, I don't know. C2, I do know, is C1 minus 1. C1, again, I don't know. That's what I'm trying to find out. And then C2, I know, is C1 minus 1. And now I'm not going to do the rest because it is homework and I really want you guys to do it, but I just want to give you some clues so you don't get panicked. Is I can basically look here on the numerator and I can see if I distribute that, don't I have a C1 squared? C1 squared means I'm going to have a quadratic. And I just have to figure out how to solve this. And all it is algebra. It's basic algebra. Right here, we don't have to do anything except get it into a form of AC1 squared plus BC1 plus C is equal to, and we'll call this Y. And that would be a quadratic equation, right?
Yep.
Okay. And then the next one just says solve it. And we already know how to solve things that look like that. We just went over it.